All right, hi geometry. We are going to do just some small chunks of section 10.1, 10.2, 10.3. I just picked out what I thought was kind of like the most important stuff that you need to know for Algebra 2 or even going up to pre-calculus. Just mainly it's a lot of vocabulary and a couple of theorems and postulates, but very few. It's mainly just vocabulary. If you have not filled out the vocabulary section first, that is the first thing that you need to do. Go find these in the online book or go look them up on the internet. Draw a illustration for each of these because I'm about to use these words during the notes, and you need to kind of understand what they are because I'm not going to explain them as I go. I'm just going to show you the examples. There's 2 full pages of it because it's really for 3 sections in the book. All right. When we draw a circle and we talk about circle, they'll usually put a little circle and then they'll always label the circle by whatever point the center point is. So this is circle P or circle symbol P. Here's some of those definitions, which are in your notes. We also have pictures describing each of these. We're going to start with identifying special segments and lines. Tell whether the line, ray, segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So the first one is segment AC. When I look at AC, it starts at the edge of the circle and stops in the center. That is the radius. And that should be a vocab that you already know from a previous course. All right, next, what do we got? AB. AB, from all the way to A to B, that's the diameter. Again, that really should be previous course knowledge. DE, starting at D, going through E, and it's a ray. DE. That touches the circle in one point only. That makes it a tangent. And this is different than using tangent as part of SOHCAHTOA. This tangent is a line or a ray or a segment that intersects a circle at one point. And AE. AE, here it is. AE intersects the circle at 2 points, and so that is a secant. Next page, my printer cut it off, but it's not really missing anything except for the title of it. Okay, so we've got a couple theorems. This theorem, I know that this is used a lot in future courses and possibly ACT, SAT tests. If you have a tangent line, it will connect to the radius of a circle at the point of tangency with 90 degrees. It will always be a 90-degree angle that connects a radius and the tangent line at that point of tangency. And then the external tangent congruence, if both tangents, so this RS and TS, if both tangents intersect at the same point, then these lengths are congruent. They'll be the same length. So here, verifying a tangent to a circle. This says, is ST a tangent? So if ST is a tangent, then this would be 90 degrees. And we can check to see if this is 90 degrees by using the Pythagorean theorem. And if it does equal c squared, then this is 90 degrees. If it's less than or greater than c squared, then this would be acute or obtuse. So we'll do 35 squared plus 12 squared equals 37 squared. And I've got my calculator to make it go a little bit faster. 35 squared plus 12 squared is 1369. And then 37 squared is 1369. So this is yes. We have a right angle, or I should say right triangle. And then, so this would be by the tangent line to circle theorem. All right, example 4, find the radius of a circle. So if I have point B is the point of tangency, and then obviously this is a radius that's marked R, then this has to make 90 degrees. Now over here it is not 90 degrees because A is not a tangent. That would be something that passes through the circle. This would be part of a secant. So the tangent AB hits at the point of tangency B. This has got to be 90 degrees. We have to find the radius. So we could do Pythagorean theorem. We could do a squared plus b squared equals c squared. My A would be like 80. My B would be R. And my C would be 50 plus R. That was really messy, sorry. 50 plus R. So over here I'm going to put 50 plus R, and then I have to square that. Now I have to square the quantity, so that gets written in parentheses. So 80 squared is 6,400 plus R squared equals, now for this side, you can't just look at it, well, unless you've had a lot of practice, you can't just look at it and be able to tell the answer. You actually have to write it twice because squared means to multiply it by itself. And then we need to multiply these together, and you could do that using the rectangular method, or we could do it using the FOIL method. This seems to be the method that a lot of my Algebra 2 students like the most. You do 50 plus R here and 50 plus R on the side, and to find the area, you just multiply the side times the side, but we can multiply them by individual terms. So we can do 50 times 50, which is 2,500. In this block right here, I would do the R times 50, so I get 50R. In this block here, I'd do the 50 on the top and the R on the side, so 50R. And then this block here would be R times R, R squared. And then we look for any like term, which these two are like terms, and we're going to add the terms together. So I will end up having 2,500 plus 50R, and 50R is 100R, and then R squared. Over here I have 6,400 plus R squared. Now we have to solve this equation, and since I've got r's on both sides, I'm going to take away this r squared. I have 6,400 equals 2,500 plus 100r, and those just both cancel out. I'm going to take away 2,500, and I get 3,900 equals 100r, and divide by 100, and r is 39. Does that make sense? Yeah, it makes sense for the picture. R would be 39. Okay, using the, what was the theorem called? The external tangent congruence theorem from the previous page. If I know that RS is tangent at point S and RT is tangent at point T, they both have the same intersection of these lines. That tells me these two have to be congruent tangents. So I will set 3x plus 4 equal to 28. I'm going to divide both sides by 3, I get x equals 8. And it says find the value of x, so x is 8. If I needed to know the length of the side, well, it should be 28. If I want to check to make sure I'm doing it correctly, then I would plug in 8 and get 24 plus 4, which is 28. All right, that is through 10.1. This is where 10.2 starts. So when you go to do your assignments, questions in 10.1 will go through this kind. Questions in 10.2 are going to start with angles. So you had to look up and find out what a central angle is, what a minor arc is, what a major arc is. Here's a picture. I've got some core concepts written down in the notes too if you need to go back to your notes and look at that rather than looking at the vocabulary. The biggest thing that you need to know that is we have a central angle, like this angle right here, which is 110 degrees, and we measure portions of the circle in degrees. When I talk about the arc, RS, and this little arc symbol is a little bit hard to see, but the arc, RS, when we talk about that arc, from R to S, that's going to be the exact same measurement as the central angle. So the central angle is 110 degrees. Oops. Then the arc that goes from R to S is also 110. And we write a degree symbol, we're measuring it in degrees. Question B says RTS, and it's with 3 letters. So that is telling me that we are doing the major arc because it's using the 3 letters. It goes from R through T to S, so we're going the other direction around the circle. It's not really showing up. I have like a really light green color. Make it messy. Kind of shows up. Okay, so from R to T to S, I'll just use a different color. Let's see, the whole circle is 360. I know that this part right here is 110, so the other direction has got to be 360 minus 110. So 250 degrees. And then finally, RST. RST. From R to S to T. I'm going to use a highlighter since I already have colors here. I'll just highlight over that one. From R to S to T is this. And I may notice that RT is a diameter. So if RT is a diameter, then R to S to T is half of the circle, which is 180 degrees. Or 360 divided by 2. Half the circle. Arc addition postule is just like all of our addition postules we've had in the past. If I take the arc AB and I add together the arc BC, then it's going to give me the measurement from A through B to C. So using the arc addition postulate, we need to find GE. So from G to E, looks like I'm adding 40 and 80 together. So 120 degrees. From G to E to F, from G to E, which is 120 degrees, to F, which is 110. So we've got 120 and 110, which is 230 degrees. And then GF, right here, that's like the whole circle, and take away the part that I just wrote down, take away that 230. So 360 minus 230 is 130 degrees. All right, and that was section 10.2. So now this is starting section 10.3 in the book. 10.3 has the vocab of an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and the sides pass through the circle as well. So the central angle, the vertex was at the center of the circle. The inscribed angle, the vertex is on the circle itself. So they've got different colors here. In red, that is a central angle. And in blue is an inscribed angle. And then there's also the intercepted arc. And the intercepted arc is just the arc that connects through those two sides of either of those angles, either the inscribed angle or the central angle. It's going to be the same amount for the arc, but you can definitely tell that this central angle is way bigger than this inscribed angle. But the degrees of the arc is the same for both. And that's, again, just saying what I just went over. So our theorem that you would use on your assignment is that when you have an inscribed angle, so we've got this angle ADB right here, that is 1/2 the measurement of the arc. So the measurement of angle ADB is half the measurement of the arc. So if the arc was 100 degrees, then the measurement of the angle would be 50 degrees. Half. So find the indicated measure. Measure of angle T. So here's angle T. So across from angle T is 48 degrees. So angle T is going to be half of 48 degrees, which is 24 degrees. And then we've got measure of arc QR. So I need to know the arc QR. Excuse me. All right, let's see. How can we do this one? I'm looking and I see that this is a semicircle. And this angle 50 degrees, I'm sorry, this is the diameter that goes through half the circle. This angle 50 degrees is telling me from Q to T is 100 degrees. And I know from R all the way around to T, R to Q to T, that's a semicircle, that's half a circle. So this one has to be 80 to add up to equal half that circle, 180. I don't know how obvious I made that. I see it in my head. I'm not quite sure how obvious I did that to you. That's the inscribed angle, that's 50. That makes that 100 degrees arc. And then we need to know from Q to R, but these two together add up to be half the circle. Okay, example 2, measurement of arc RS. So RS is right here. And measurement of angle STR. Angle STR. So we're going to find those measurements. So I think I can find arc RS by using this given angle. This angle is an inscribed angle, which means it is half of the measurement of RS. So if this is half of that, I'm going to multiply both sides by 2, and I get 62 degrees is the measurement of RS. So now if this one is 62 degrees, now we need to find this angle. And I go and I look for the ends of that angle, and they are exactly the exact same ends of angle U. They are at S and R, which has an arc of 62 degrees. So this angle has to be half of the measurement of arc RS, which we already know the measurement of RS is 31 degrees because, oops, I just did that backwards. Well, yeah, we can do it that way. So the measurement of angle T is 31 degrees because we already know half of the measurement of RS is 31. So measurement, they're calling it angle STR. Is 31 degrees. So what do you notice about angle STR and angle RUS? Well, they're congruent. They're exactly the same measurement. And how do we know that? Well, that's the inscribed angles circle theorem. So if we have two inscribed angles, so in here it's angle D and angle C, two inscribed angles, and they intercept the exact same arc, so their endpoints for both of these are at A and B, then the angles are going to be congruent. All right, last part of this is inscribed right triangle theorem. So if we have the diameter, and then we have an angle that is an inscribed angle, and its endpoints are the diameter, this has to be 90 degrees. Now we can get that from the previous, not this theorem, but the one on the other page, I forget what it's called. The theorem 1010, which is measure of inscribed angle theorem. If I know that from A to C over here is a semicircle, it's 180 degrees, and I take half of that, well, this is going to be 90. So any triangle formed where the endpoints, or I should say any angle formed where the ends are at the end of the diameter, that's always going to be a right angle. And then if we have a quadrilateral, an inscribed quadrilateral, all four angles have to be on the circle. All four of them. If one of them is not, this is not an inscribed quadrilateral. So if all four angles are on the circle, then we have a theorem that says the opposite angles are supplementary. So what does that mean? Opposite angles, like angle D and angle F, they're not the same, they're supplementary, which means that they would add up to equal 180. That would be different than angle E and angle G. These are also supplementary. They also add up to be 180, but that does not mean that like E and D are congruent. It just means separately they're going to add up to be 180 each. So if we have, find the value of each variable, if we have a angle C, which is inscribed in a circle, its endpoints are A, B, which are the endpoints of the diameter. That tells me that angle C is 90 degrees. And here it says 2x is angle C. So if 2x is 90 degrees, x has to be 45. In this one here, we've got an inscribed quadrilateral. So all four angles are on the circle. What we know about that is that the opposite angles are supplementary. So y degrees plus 120 degrees has to equal 180 degrees. So y is 60. And z degrees plus 80 degrees equals 180 degrees. So z is 100. Not degrees, sorry. The degree symbol's already there. We don't need to write it twice. All right, you guys are going to have like 3 separate big ideas assignments, but they're going to be short. I was able to do all these notes in 25 minutes. Now, I did not spend a lot of time going through it because you have to do that vocabulary first. But make sure you go on Big Ideas Online and you do all 3 of these assignments. They will not be super long. And then use your notes because that's a lot to learn from just a short video. So make sure you keep those handy, and I will talk to you guys soon. Have a great day.